Today we are here again for Structure of Atom Chapter 4, and that is going to be lecture number 3. So in this topic we are going to do some important topic which will be a recapitulation of chapter 3 because already we have done in that. Okay, so hope you will get this very easily. So let's start with this. So today we are going to do about this electronic configuration. That means how the electron will be distributed among that all the orbits. And we have already done about the orbits in the previous lecture only. That orbits are the circular path in which the electrons revolve around the nucleus. Hope it is clear to you. And orbit were named as KLMN. Yes. Or if we give the numbering, it will be 1, 2, 3, 4, 5, something like that. Yes. So today we are going to understand about this, that how the electrons will be distributed in that, orbits. Okay. So the distribution or the arrangement of electrons in different shells of the atom is called electronic configuration of the element. Yes. So next, to write the electronic configuration, we should know the following things, and that are the first thing, the total number of electrons present in atom, which is always equal to number of protons in case of neutral atom. And if it is not neutral, then obviously it won't be equal. And I have already discussed about the formula by which we can find the number of electrons in the cation or anion. Yes, and number of proton is also equal to atomic number. So if the element is neutral and we know the atomic number, we will be easily able to write the electronic configuration of that atom. Second, the maximum number of electrons that can be present in each shell of the atom. That is very important. You have to learn that. You should know that what is the maximum electron which can be present in any shell of the atom. So electronic configuration, the rules are follows. Like electronic configuration is based on certain rules given by Bohr-Bury scheme. According to this scheme, the maximum number of electrons which can be present in any shell of an atom is given by formula 2n square. That means this formula 2n square will decide the number of electrons, the number of maximum electron present in any shell, where n is the number of shell as counted from the nucleus according to 1, 2, 3, 4 like this. And the formula is like, so let's start with this, like how to calculate that. Maximum number of electrons in first shell. First shell is just closer to nucleus, and for that the orbit number is mentioned as 1. So total number of electrons will be 2 into 1 square. That means it is going to be 2, isn't it? Similarly, if I will ask about the L shell, so the formula is same, but for L, the n value, the orbit number will be 2. So what will be the number of electron in the second shell? Yes, of course, by the same formula, 2n square. That means 2 into 2 square will give you 8. Yes, like this. Similarly, if I will calculate for M shell, the n value is 3. So 3 square will be 9, 9 to the 18. And that means the maximum electron present in the third shell will be 18. And similarly, we can do that for the fourth shell, K shell, and that is, it should be N, not K, it will be N. Okay. So in the N shell, number of electrons will be 32. So this is according to Bohr rules. Bohr has given that electron will be occupied like this. In the K shell, the maximum electron can be 2, less 1 ho sakte hain. L will have 8 electrons maximum. M can have 18 electrons maximum. Similarly, N can have maximum 32 electrons. But there is some problem in that. So let's see. The outermost energy shell in an atom cannot have more than 8 electrons, even if it has the capacity to take up electrons according to the first rule. The first rule was that in the K shell it is 2, in the L shell it is 8, in the M it is 18, and in the N it is 32. But another rule, same Bury, in association with the Bury, it said that any shell except K, any shell cannot have maximum, cannot have more than 8 electrons, even it has the capacity to take electrons. चाहे उसके पास कैपेसिटी हो या ना हो, but it cannot have more than 8 electrons. So that means in the M shell as well as for the N shell, the maximum electron will be what? 8. Yes. So for example, the M shell is outermost shell of an atom and it can accommodate maximum of 8 electrons only, although M shell has the capacity to accommodate maximum of 18 electrons. An atom becomes stable if it stops reacting chemically with other elements. If it stops reacting, then this will become stable, or vice versa. You can say that if it is stable, that means it is not going to react, and if it is not reacting, you can say that it is stable. In the both way you can say. So when it will stop reacting, when its outermost shell has the maximum electron, that is the 8 electrons, the 8 electrons it wants, and if it is having, that means it is not going to take up or lose the electron, isn't it? So it has only one shell containing 2 electrons, and the penultimate shell, that is the shell preceding the outermost one, just before the outermost jo bhi hoga, that will be called penultimate shell. Yes, can accommodate maximum of 18 electrons. So I hope this thing is not clear to you. So let me explain in some easy way. That is the magic number you have to understand. And it is like, let me write over here. This is 2. Okay, so this is the magic number 2, 8, 8, 18, 18, 32. It says that in the first shell, in the first period, if element is in the first period, it has only K. So it will have maximum 2 electron. If it is having L shell also, that means second period, second orbit, then it will have 2 and 8 maximum. Even in the third shell also, although it has the capacity to gain 18 electrons, but it will have maximum of 8. For the fourth shell, it will be 18. Fifth shell, fifth orbit, it will be again 18. And for the sixth, it will be 32. So this is the magic number. And according to this only, the elements will, the electrons will be distributed among for the atom. You don't have to remember all this. You have to see that K shell will have the 2, L will have 8, M will maximum have 8, and whatever left, because you have to learn till calcium. So calcium, that means 20. So if till then calcium, whatever the left electron is there, just send it into the last shell. That means that's it. That will be enough for you. Okay. So electrons will be filled like 2, 8, 8, and whatever left will be in the N shell, but not at all more than 18. Electrons do not go into a shell before the inner shell is completely filled. जब तक अंदर का शेल फिल नहीं हो जाएगा, इलेक्ट्रॉन विल नॉट गो टू न्यू शेल. दिस इज क्वाइट क्लियर. मतलब K shell can accommodate maximum 2 electrons. So first 2 electrons has to be accommodated, has to be filled with this K shell, and then only the extra electron will go to the L shell, and similarly for M or for N. Yes, like this one is. So in that shell, only this, according to Bohr concept, this is the 2 electrons will be accommodated over here, second 8, third 18, fourth 32. But this, according to this, we cannot fill the electronic configuration, we cannot do the electronic configuration. What we will do, even in the M shell also, the maximum electron will be 8. And whatever rest electron will be there, that will go to the N shell. I hope it is clear now. Yes? Okay. So the electronic configuration of an atom helps in determining the chemical behavior of an element. How it is? When the atom of an element is completely filled, outermost shell, matlab like, I have given you the maximum one, having 8 electrons in the outermost shell, or 2 electrons where the outermost shell is K. Agar K shell is the outermost, there should be only 2 electrons. But if other than K hai, to wahan pe kya hona chahiye? That should be 8. So will be chemically unreactive because already its orbit is filled. So that means it is not needed. It is not in need of accepting any electron or losing any electron, isn't it? So in that case, it will be considered as unreactive. And for example, the noble gases like helium, which atomic number is 2, neon, whose atomic number is 10, argon, which is 18, etc., have completely filled outermost orbital, and hence noble gases do not participate in the chemical combination. So it can be asked as a question that why noble gas do not participate in the chemical reaction, or why noble gases are unreactive. Okay, or name a element which is unreactive. So you can like this. So why का answer, the first two questions will be answered like Since noble gas has 8 electrons in its outermost shell, so it is not needed any electron. Yes, so that's why it will be completely like unreactive or do not participate in the chemical combination. So next is when the atom of an element has less than 8 electrons in its outermost shell, the element will be reactive. If the outermost electrons are less than 8, in the outermost shell the electrons are less than 8, then in that case the element will be reactive. And in that case it will be either lose the electron or gain the electron. That will decide its valency. So we'll do afterwards like this. Hydrogen has element is like H11. So number of neutrons, you know that it is A minus Z kaho or A minus P we can say. Number of proton is like this, which is written over here as a subscript. Number of electrons will be equal, and the electronic configuration, if you look in the K shell, only one electron. And how to draw this? This is the nucleus, which will have one proton, and here it is revolving in an orbit, one electron. Yes. Now helium. Helium has 2 atomic number. So proton will be 2, electron will be 2. At electronic configuration, if I will talk, it will be 2 only. Yes. And in this electronic configuration, the nucleus is here, which is having two protons and 2 neutrons, and 2 electrons are revolving around this, that 2 in the K shell only. Yes. So only one shell we will make, and the 2 electrons we will. Similarly, lithium, if I'm talking about, there are the 3. So 3 atomic number, that means proton will be 3, electrons will be 3. So if I will talk about the electronic configuration, the K shell can have maximum 2. So other third electron has to go in L shell. Yes. And number of neutrons, if you want to find that subscript minus superscript minus subscript you do, you'll get the atomic number of neutrons, isn't it? So drawing this, in the center, the nucleus will have the 3 protons and 4 neutrons, and 3 electrons are revolving, 2 in the K shell, 2 in the K shell, and 1 in the L shell. Yes, clear? Similarly, for beryllium, we can do like this. I hope it is clear. If there is any doubt, you can ask. Similarly, for boron, carbon, nitrogen, oxygen, I have done. So you have to practice it. Yes. Fluorine, neon, sodium, magnesium. You can see, just let me take one. This is neon. Atomic number is 10. Proton will be 10. Electron will also be 10. And if we talk about the electronic configuration, this is going to be 2 and 8. So the outermost electron has 8 electrons. That means it is completely filled. So it is going to be unreactive because it doesn't need any electron. So ये react नहीं करेगा. Yes. And to make to show this distribution, 10 neutrons and 10 protons will be there in the nucleus, and 10 electrons, 2 in K shell and 8 in L shell, will revolve around the nucleus. Yes. Similarly, sodium, magnesium we can do. Aluminium, silicon, phosphorus, sulfur we can do. And chlorine, argon, potassium. Calcium we will do. Let's see this potassium. This is potassium. Potassium is 19. So atomic number is 19. So proton will be 19. Electron will also be 19. And if we talk about the neutron, this is superscript minus subscript, 39 minus 19, 20. So electronic configuration will be 2, 8, 8, and whatever left you have to send in the N shell. So drawing 19 proton and 20 neutrons will be there in the nucleus. There will be 4 shell. So one shell is this K, which is having 2 electrons only. You can see that 1 electron and 2 electron. L shell will have the 8 electrons, isn't it? Similarly, M shell will also have 8 electrons. Here it is M, 8 electrons, and N shell is having just 1 electron. So it is like that. Clear? Similarly for calcium. So till this point you have to learn. Now there is next topic, that is ions. So I have told you that in the neutral case, the element are having same number of protons and electrons, and in that case they are stable. But what's the need to form an ion? Why atoms exist as ions? Yes. So let me explain this. Ions are electrically charged species. Ions will have either positive charge or negative charge, and according to this it is of 2 types, cation and anion. an ion, why it is formed? Like see, sodium we have done 281, isn't it? So it is not stable. It is, as I told you, that it is having last shell, it is having only one electron. And to make stable, to be stable, every element should have 8 electrons in its outermost shell. So what will happen? The sodium has a two option. Either it will lose 1 electron, yes, or it will gain 7 electrons. So which one is the better condition? Lose 1 electron or gain 7 electrons? See, let me write over here, sodium. This is 281. We have to make that outermost shell, whatever the outermost shell will be there, that should have 8 electrons, except K shell, yes? So it has two options. Either it gains 7 electrons and it gains 7 electrons, sorry, let me write over here. And in the M shell also it becomes 8. Yes, it becomes 8 like this, we can say. Or the another option is it will lose this 1 electron. ये जो एक electron है वो lose कर दे, so that it will have the 2-8 configuration. And again, this is outermost shell is having 8 electrons, isn't it? So there are the two options. Which option it will occupy? For sure, less work, more benefit. In both the case, it is going to be stable. But in this case, it has to do less work. But while in this case, it has to do more work. So obviously, less work, more benefit everyone wants. So what it will do? It will lose 1 electron and be stable. So in that case, it will be, now sodium is going to lose the electron. So if the sodium loses electron, it will convert into cation and it will have positive charge. Clear? So to make Y atoms exist as ion, or Y atom forms ions to make itself stable. Okay, like noble gases. Got it? An ion is formed by loss or gain of electrons by an atom. So it contains an unequal number of electrons and protons, because वो unequal हो जाता है number of electrons and protons when it forms ions. So in the case of cation, the number of electrons will be less than protons, while in the case of anion, number of electrons will be more than protons. We have already done. There are the two type of ions. One is called cation, which is having positive charge, cation, positive charge. Yes. And anion, that means negative charge, anion. Clear? So what is cation? Cation is positively charged ion formed by loss of 1 or more electrons by an atom. For example, sodium ion loses 1 electron to form sodium ion. Right now we have done sodium, it should be atom, not ion. Sodium atom loses 1 electron to form sodium ion. Yes? Formation of cation. If an element has 1, 2 or 3 electrons in the outermost shell. Now, what is the easy way to identify whether it will form cation or anion? So just remember, write the electronic configuration, and if the last shell is having 1, 2 or 3, if the last shell is having 1, 2 or 3, then this atom will lose the electron, otherwise it will gain the electron. Got it? समझ में आई बात? So if the last shell is having 1, 2, 3, it will lose the electron and it will convert into the cation. So example, like this is 281, it will lose the 1 electron and it will convert into 2-8 configurations, Na+. Yes? Now anion. Anion are the species which negatively charged ion formed by gain of 1 or more electrons. Okay, it gains 1 or more electron by an atom. For example, chlorine atoms gain 1 electron to form chloride. Let's see. If an element has 5, 6 or 7 electrons in the outermost shell, it will gain the electron. Similarly, the same case, if chlorine is there, so configuration is 2, 8, 7. It has two options. Either it gains 1 electron, to convert into like 288. Yes, or it will lose 7 electrons. Agar 7 electron lose kar dega, then also the last shell will have 2 and 8 electrons will have. So in the both case, it is going to be stable, but here more work and stable here less work and the same stability. So obviously it will do that small work, less work, and get more stability. So that means it is going to gain 1 electron. And if any element, the short way, if an element is having 5, 6 or 7 electrons in the outermost shell, it will gain electrons to achieve the stable inert gas electronic configuration. Clear? And if it is having only 4, if it is having 4 valence electron, that means outermost shell will have 4 electrons, then it will neither lose nor gain. It will share the electron, that we will do in class 10th. Okay. So this is then. So that's it for today. And I hope you got the concept properly. Go through with the video properly and make short notes, practice it. We'll meet you in next video with the next topic, that is going to be isotopes, isobars, and their properties, something. Okay. So till then, thank you class. Enjoy your study.